Thanks. Yeah, hi, I'm Till, and today I want to tell you a little bit about how Apache Flink integrates with Apache Mesos and how easy it is to deploy Flink clusters using DCOS. In case you might wonder who this second person is on the slide, it's not my alter ego, but Jörg couldn't be here. He apologized for that, so I will take over the Mesos part as well and try to answer like Mesos and DCOS related questions as good as possible. All right, let's get started. So this is how data centers looked like 50 years ago. You had a room filled with a single computer, sometimes even been operated by humans, processing little data at a slow pace. Compared to that, today's data centers look a bit differently. They have a room filled with hundreds of thousands of machines on which you can compute billions or trillions of events per day. Compared to how the data centers developed and progressed, so also did the data processing systems. So if we compare MapReduce with today's data processing systems, it might seem as if MapReduce is from a completely different time, where we had to batch our data, and once in a while we kicked off a MapReduce job, crunching the data to produce the results which fueled our dashboards or produced the billing information for accounting. Things changed a bit. Today, data processing systems have to produce results quickly. So ideally, as fast as possible, near real time, because this gives companies a competitive edge over its rivals, allows to build new services and products which they can sell to their customers. So if we take a look at the evolution of data analytics, we see that by decreasing the end-to-end latency of these data processing pipelines, we were able to build more and more sophisticated applications. So starting with batch processing, where we had an end-to-end latency of hours to days. Back in the days, we used it, as I said, for calculating billing, or we could do like compute product recommendations, which were kind of static, if you wish. By decreasing the latencies to minutes to seconds, we were on the scale of microbatches. Using this, we are able to realize applications like real-time pricing and routing, for example. But the truly sophisticated applications are only possible with event processing, where we talk about latencies of milliseconds to microseconds. Having this kind of, these capabilities, like producing results within milliseconds, we're able to do real-time advertisement as well as building predictive user interfaces, which is quite cool. So in order to do event processing, the technological stack had to change a bit. And people can now use the FMEC stack, which comprises of Flink, Mesos, Akka, Cassandra, and Kafka. So what are these individual applications used for? So everything starts with events, which we collect somewhere, like for example from sensors, devices, or clients. These events are ingested into Kafka, where they are made accessible for our analytical component, which is Apache Flink. Apache Flink can be used to do real-time processing as well as batch processing if needed. The results of this analytical process can then be stored into Apache Cassandra, for example, if you don't want to rely on Flink's queryable state capabilities. And from there, you can build small applications using Akka to visualize the data or to build data-driven applications. For the data-driven applications, you could theoretically also use Flink's process function, so if you don't want to rely on Akka. All right. So now we've talked about what applications we have. Now let's talk about how we actually run these applications. And this brings us back to our data center. So if you want to run all these applications, a very naive approach would be to allocate for each service a dedicated set of nodes or rack, for example. So here we have a dedicated node for Flink, Kafka, MySQL, for some microservices which we are running, and Cassandra. This is nice from the isolation perspective, but not so nice from the resource utilization perspective, because usually what happens is, because you don't know the maximum load for your different services, that you over-provision. This basically leads to a waste of computation resources, which is the same as money, and this is bad. Like the industry average of resource utilization is between 12 to 15%, which gives a lot of room for improvement to use these free resources reasonably. This is basically where Apache Mesos comes into play. Apache Mesos is a cluster resource management system which allows you to run multiple applications on a shared set of resources. So using Mesos, we could, for example, run the same set of services, not on 5 machines, but on 3 machines by sharing the resources. And what we don't lose with Mesos is the isolation. So Mesos will make sure that the different applications don't interfere with each other using C groups and namespaces. And that way, we basically have a much better resource utilization and can decrease our costs. What else speaks for Mesos? Well, first of all, Mesos allows you to build fault-tolerant applications. So it monitors them, and if things break, then the application will be restarted. Furthermore, it is proven that it scales to up to 10,000 plus nodes. I think there are companies running it on the scale. It's used by more than 100 web-scale companies, proving that it's also battle-tested. And it has a nice, a bit different approach to scheduling, where it puts some of the responsibility of resource scheduling in the hands of the Mesos application, which allows to have a bit more flexibility, if you wish. All right, that's all for the introduction of Mesos and motivation. Now let's take a look what it all has to do with Apache Flink and how Apache Flink can use Mesos. So first of all, Apache Mesos gives functionality, or offers the full functionality to build distributed, elastic, and fault-tolerant applications. And this is exactly what Apache Flink is. Thus, it's a perfect fit. Moreover, a very interesting funny fact is that back in September 2016, we conducted a survey and asked our Flink users how they're running Flink. And around 30% of the users responded that they are running Flink on top of Mesos, even though back then Flink didn't have a proper Mesos support. So they basically built it on their own. So this was reason to finally offer a proper Mesos integration. Okay. Now let's take a look at how Apache Flink integrates with Mesos. So in the Mesos world, applications or things running on Mesos are called frameworks. So that's why we call it the Apache Flink framework. The Apache Flink framework consists of the Mesos App Master, which runs the Flink Mesos Resource Manager, and the Job Manager. The Flink Resource Manager is responsible for talking to the Mesos master. And its task is to allocate new resources, which means starting new Mesos tasks, which run the task managers. And up in initialization, these task managers will register at the job manager, which runs in the Mesos app master. And once the job manager receives these registrations, it knows it can start executing the job by deploying tasks to these task managers. And that way, it executes the Flink job. That's the rough overview of how the different components interact in the current integration with Mesos. The actual Flink Mesos Resource Manager is a bit more sophisticated. It consists of the following 4 components to realize the integration with Mesos. So we have the connection monitor, the launch coordinator, the task monitor, and the reconciliation coordinator. The responsibility of the connection monitor is to monitor the connection to Mesos, as the name might indicate. And it tells the framework, the Flink framework, when there's a connection problem to the Mesos master. The launch coordinator is responsible for receiving resource offers for Mesos and matching them together with matching them to tasks it is supposed to start. And here tasks mean task manager. This is done by using the Fenzo scheduler, to which I will come in a minute. And once this matching has been done, it tells the Mesos master which tasks to start where. Once a Mesos task has been started, these tasks are monitored by the task monitor. And the responsibility of this monitor is to basically tell when a task has died and decide when the internal view of the framework, like which Mesos task it has allocated, diverges from the Mesos view. And if that happens, it would trigger a reconciliation with the Mesos master. And this reconciliation is done by the reconciliation coordinator. So it will basically talk to the Mesos master and check which Mesos tasks are still running for this for the Flink framework. Okay, this might sound a bit like abstract. Now let's take a concrete look at how these different components play together. So the resource manager wants all these 4 components, and let's start with the connection monitor. So you have the Mesos master, and the connection monitor listens to the status messages from this master, and that way you can tell when a connection when the connection to the Mesos master has been lost. The launch coordinator is told how many task managers to start. That's indicated by these blue triangles. Additionally, it receives from the Mesos master periodically resource offers, and it tries to match these resource offers with the tasks to start, and tells after matching Mesos where to start the tasks. Additionally, it notifies the task monitor about the launch tasks. Once Mesos has started the Mesos task, which runs the task manager, the task monitor receives status messages from this Mesos task and can tell whenever a task, for example, has died. And this will then can trigger reconciliation, as I've told you, which means that the reconciliation coordinator talks to the Mesos master to see which tasks are actually still running. This reconciliation is also triggered in case of a resource manager failover, where the resource manager has to recover all the currently running Mesos tasks for this framework. That's basically the same code path. All right. I mentioned Fenzo before. So Fenzo is, if you wish, like a generic scheduler for Mesos frameworks, which is developed by Netflix and does all the logic necessary to match tasks to resource offers. The nice thing about Fenzo is that it is quite pluggable. So, for example, you can plug in different fitness evaluators, which tell you, or which basically decide which matching is optimal, or which matching is better than others. So, for example, you could say, I first want to spread my task across as many nodes as possible, or you could say that a matching is better if I first try to fill up a single machine before I go to the next machine. That is possible. So, just to show you how it works internally. So I told you the launch coordinator is started with the, it's told how many tasks to launch. It receives these tasks, the resource offers, which it gathers over a short period of time to collect multiple offers, such that Fenzo has some resource offers to choose from. And this is then given to Fenzo, and Fenzo returns the resource task matchings. All right. In one of my previous talks, I mentioned that we are currently reworking Flink's distributed architecture, which will add the functionality for dynamic scaling, making Flink finally fully resource elastic. This distributed architecture, or this change, will also affect the Flink Mesos framework. So the thing we will add basically is, or the new thing is the Flink Mesos dispatcher, which is will be like the entry point to the cluster. So when you start a Flink cluster on Mesos, what you would do is you would register it with Marathon, or you would tell Marathon to start this Flink Mesos dispatcher. Marathon is a service which makes other services highly available on Mesos. Then, once this Mesos dispatcher has been started, the cluster will, the client will only talk to this dispatcher. You will send it then a job graph, the job which you want to start. Then the Mesos dispatcher will talk to the Mesos master to allocate a new container or a Mesos task, starting the Flink master process. Additionally, the Flink Mesos dispatcher will monitor the Flink master process and is responsible to restart it in case of a failure. This makes the Flink master process highly available. All right. An additional change is that the job manager now is only responsible for a single job. So you start for every job one of these master processes. The job manager then will start trying to execute the job, and for that it needs some resources, like slots to deploy the tasks to. This will be, this will trigger a slot request, which is sent to the Flink Mesos resource manager. This will then trigger the start of new Mesos tasks. Once these tasks have been started, they will register, the task manager will register at the Flink Mesos resource manager, making available their task slots. And these task slots are then given to the job manager, and the job manager then finally can start executing jobs by deploying tasks into these slots. And that's how we want you to make add dynamic scaling capabilities to Flink. Okay, so much for the Flink integration. Now let's take a look at DCOS. So in a data center setting, you usually have many microservices running, usually in containers. You have other services running, like databases run in your data center. You have some systems for streaming or batch analytics or machine learning. And what all these services have in common is that they need some services to be executed. So for example, they need, if you want to run them in containers, they need something which does the container orchestration. They need usually an authentication service. They need to be monitored and somewhat interacted with respect to operations. And ideally, there is something like a user interface with which the user can interact to start and stop these services. And that is basically, in a nutshell, what a DCOS, the data center operating system, is. It basically offers these basic services to run other services on top of your data center. And additionally, well, you can also think of it as a bit of an app store for data center applications, which you can easily pick and deploy in your data center and then operate using DCOS. And this is what I will show you in a bit with a quick demo. So first of all, let me introduce the demo. What I want to show you is I want to run a Flink application, which is deployed with a Flink cluster deployed via DCOS. And this Flink application does some financial transaction fraud detection. For that, we start a generator which generates financial data or financial transactions, which are stored in a Kafka topic. This Kafka topic is consumed by our Flink application, and we say, and then the Flink application will group the transactions by origin and target and calculate the accumulated amount of transactions within a 10-minute window. And we say if this amount exceeds, let's say, 10,000 euros, it looks a bit suspicious and could be fraud. And these kind of transactions will then be written out to another Kafka topic for further processing. Yeah, that's what I want to show you. And I hope, let's pray to the demo gods, that everything is working now. Jörg was so kind to set up a DCOS cluster, which we see here. Yes. So we see that there's a DCOS cluster with 4 nodes. We have 16 cores there, 55 gigabytes of RAM, and some disk space, and no services running so far, so it's empty. I've spoken about the App Store. This is we can also call it the catalog. Here we see all different kinds of application which you can start and deploy via DCOS. So here, for example, is Flink. We've seen Kafka. We've seen Cassandra. There's a bunch of these. And you can do this via the UI. But for the demo purposes, I will use the CLI. And the first thing to do is to authenticate with the cluster, which I will hopefully do here. So the username is bootstrap user. The password is secret. And we logged in successfully. All right. First thing to do is we need a Kafka service where we can ingest our financial data into. So we do this by DCOS package install Kafka, which will hopefully install Kafka. So it asks us whether we want to continue installing with some, how much resources we want to give it. It will be registered with Marathon, making it highly available. And it tells us that we have now a new command available on our CLI, DCOS Kafka. So let's quickly check whether it's running. We can take a look at the endpoints it registered for the brokers. And apparently, it couldn't find it. Let's check on the here. So Kafka is running apparently. So let's try it again. Oh yeah, now it could find it. Apparently I was just too quick to type it. It needed some time to come up. So here we see Then we have two brokers registered under these IPs. And yeah, it seems to be running. All right, perfect. Next thing would be to start our generator for the financial data. There, Jörg prepared a small Go app generating this data, which we can start via. Let's see. It starts by. Where's my cheat sheet? Generator JSON. All right. This does the trick. No, it's the wrong copy. Okay, this should start the generator app, which now generates financial transaction data, which is puts into Kafka. Next, let's install Flink. Basically works the same as with Kafka. We type DCS package install Flink. Then we are installing Flink. Oh, actually, I forgot one thing to do, which is to add the Kafka topics, which might be problematic. So let's set up the Kafka topics. We need Ford, and first I delete the generator service, because, wait, where do we go here? We can, because of course the generator needs a topic to write the data to. All right, so first we create the for topic. I think it's maybe topic. So we created our for topic, and the other name of the topic is transactions. That's where we output our Flink results. Okay, there exist already transactions, which seems to be okay. Then we don't have to create it. All right, now we deploy our generator app. Okay, and hopefully we have launched our Flink service by now as well. Let's see. It's still oh yeah, it's up. So we have a Flink cluster running on DCOS, and hopefully some data in our Kafka topic. So let's deploy our job. So I built this job before. It's quite simple. It consumes from Kafka, has a sliding window of 10 minutes with a slide of 2 minutes. Before it groups the transactions by origin and target, and then accumulates the transaction value. So here we go to demos, Flink 1.9, Flink job, target. Here's our Flink job. We upload it. Hopefully it is fast. Well, that's the internet connection here. So what we are doing now is we're uploading the Flink jar, which we can then submit by using the web client or the web front end here. This should happen anytime. 69%, 76. Just too many speakers on the speaker Wi-Fi. And it's done. All right. So we have our Flink job uploaded. Now let's start it. This will submit the program and start executing. So this is, you see, quite simple topology. And here we should see that it consumes some data if there's some data in the Kafka topic. Oh yeah, so there seems to be something, because here we see byte sent and received. Now what we can do is to visualize the results. Jörg provided another Go or like Akka program which simply reads the output topic and prints it to standard out. We go to display. We go to it's not yet started yet. Wait. Where does it go? So we have to wait for the logs, which are not visible yet. So where are they? Or they should be visible here. Pardon me? Instance? Ah, this. Oh yeah, you know it better than me. Cool. Standard output, and oh yeah, here you see some detected fraud. So apparently, our Flink job is doing something. Whether it's true fraud or not, that's still up to decision. All right. So much for the short demo. That should basically show you the few steps necessary to deploy a Flink cluster and run a Flink job. And this brings you directly to the conclusion. So what have you seen today? So now Apache Flink also has a proper Mesos integration, so users don't have to build it themselves anymore. We are using Fenzo for the offer task matching. With the new distributed architecture, we will finally have full resource elasticity on top of Mesos. And I hope the demo, apart from finding the standard output, showed that it's quite easy to deploy a Flink cluster and run any Flink job. So if you have DCOS on your cluster, then you can easily give Flink a try. And yeah, that's all. I hope you enjoyed the presentation, and thanks a lot for your attention.
Thank you. Questions?
Hi. Do you need the zookeeper for the new architecture with high availability?
We need some kind of lead election mechanism, basically, and Zookeeper is one way to do it. So at the moment, the lead election services are implemented for Zookeeper. In the future, there might also be other frameworks or other tools be used for that. But in the first iteration, it will require Zookeeper as it does now.
Hi. We saw yesterday that the new Data Artisans platform, while it's running on Kubernetes, is deploying a Flink cluster per job. And I also saw on your slides today that you're, I don't know if it's now or in 1.4, you're going to have one job manager per job, but it does still seem like we're only going to be deploying one Flink Mesos framework. Or is the recommendation to deploy a Flink Mesos framework per job?
Well, it's up to the user, basically. We will support for Mesos per job as well as what we call session clusters, meaning that you can run multiple jobs in the same cluster. The only difference with the new architecture is that you will have, if you run multiple jobs in the same cluster, that you would have multiple job managers started. So this not necessarily means that you have to redeploy over and over again a new Flink Mesos framework if you decide to run it within a Mesos Flink session cluster.
But is that sort of like the best practice for containerizing Flink, is to do one cluster per job? Was there a particular reason why you guys did that for the DA platform?
What we've seen among our users is that many users prefer to run a single job on a cluster, so have a per job cluster, because it, at the moment it gives you better job isolation, if you wish. So jobs cannot interfere with each other. That's what it gives you. The session clusters are mainly used if you have more of a short-running jobs, like batch jobs, for example, where you want to share resources. And I mean, for like streaming jobs, which are usually long-running, this is usually not the problem. Like you bring it up once, so the starting overhead is compared to the runtime quite low. And so I would recommend, if possible, using the per job cluster.
Hey, how is latency affected by the new design? Latency of starting jobs, of course, that's what I mean. Is it very large, especially on large clusters? Is it significant? So far we didn't measure the differences yet. We hope that there won't be an increase in latency, and actually we think that, or we hope that that's actually improves, because right now, especially for submitting jobs to the Yarn cluster or on the Mesos cluster, it works. It's a two-stage approach. You first start the cluster, and then you it's a bit clumsy. You poll the cluster to wait until all resources have been started, and only then you submit the job. In the future, how it will be is that when you start the Flink framework, it already contains the job jar. And once it starts, it directly starts executing the job. The only time it needs to wait is until Mesos or Yarn has allocated the required containers or Mesos tasks to start the task managers. So the idea, or I hope that doing by streamlining this submission processes, we will actually decrease a bit the startup latency yearly.
Who is going to support this, you or Mesosphere? The important question.
The DCOS integration is mainly supported, or is supported by the Mesos community. The Mesos integration, so the Flink Mesos integration is supported by the Flink community.
In reality, it's very hard to figure out where the problem is.
If you're using DCOS, I mean, depending on whether Mesosphere decides eventually to not only add it as a community module, but as a fully supported module, I guess they will be the first contacts when using DCOS, I assume. But this is not yet. I mean, we haven't talked about that. But if things are wrong on the Mesos, like on the Mesos integration side, like how Flink interacts with Mesos, then it will most likely be us. So.
And the timeline questions, when do you think Flip 6 is going to be ready? And you also talked about integration with Mesos, but the application manager today is on the Kubernetes. So what's the time frame for application manager to be on Mesos as well?
For the application manager, I cannot really tell. The idea is there to primarily focus on Kubernetes right now. For Flip 6, the goal is to include it into the 1.4 release. Good parts of the code base of the Flip 6 changes are already merged. Also like the Mesos integration part. What's still missing is a bit the client-side integration, the web UI support, and testing, because it's a major change. It touches many components, and we want to be sure that we don't have regressions with it. Hopefully, it will be. I mean, yeah, it's hard to tell like an exact date for that, but it should be like in the next month or 2 months that this should ideally go in. That's the. I mean. Part of it actually, like the dynamic scaling with Mesos, for example, already works. It's just not possible to submit jobs to that because the client is not done yet. Yeah.
I just had another quick question about the multiple cluster deployment. Do you use a single place to store the checkpoints and recovery information, or are you supposed to separate those?
Usually, this information is bound to the cluster, so every cluster will be configured with a different location. But you can also configure it to use the same location, but then there might be interference which you don't want to have.
And are you able to start a job with a save point that was saved from another cluster in another cluster, or is that information required to come from the same spot? I guess.
Well, to start from the same save point, the save point has to be somewhat accessible from this other cluster, but then it shouldn't be a problem to do so.
Any more questions? Thank you very much.
Yeah. Enjoy the lunch, and thanks for the attention.